Good afternoon, everyone. Am I audible? Can I thumbs up? Okay, cool. Thanks for joining the session. If it shows up here. So this, while we are working on getting the sessions on the screen, this is about securing your web-facing applications using AWS security services and creating a kind of self-defending border, right? And I have a co-presenter today with me. His name is Venkatesh Sundar. He's the founder, CTO turned CMO for Indusface, who is one of our partners who create web application firewalls, right? So what we're going to do today is just show of hands, how many security professionals in the room, right? So there's few. So I think I'll spend some time over talking about the types of threats we see out there, and then talk about AWS services which you can use to mitigate those threats, right? So let's start with types of threats. You can broadly classify them between three areas. One is denial of services attack, distributed denial of services attack, application attacks, and bad bots. Bad bots means the attacks which are used to exfiltrate data or steal your content, right? And on the other side, you can classify them as at application layer or network transport layer, right? So most of the network DDoS attacks are on network and transport layer, and mostly you would see that as resource exhaustion attacks or state exhaustion attacks, where the bad actor will send a lot of traffic towards your resources, and they will deprive the legitimate users from using your resources, right? So examples are DNS reflection attacks or SSDP reflection attacks, right? Similarly, on application layer, the denial of services attack comes from activities where the bad actor will try to run the resources out or the state of for example, a web server out, right? So if you are running a web server, the bad actor will try to open as many a session it can and not send any data on that session, which will consume the or which will make the limit for the web server. It will reach the limits for the web server will be reached, and no more new sessions will be able to serve content to users, right? Same way, the next type of attack which we see out there is exploit code, where the content exfiltration is attempted using malformed packets or SQL injection attacks or cross-site scripting attacks. And the last type of threat we see out there, which is very popular, is scraping the content, or we call it crawling, where a bot is going to scrape your website or your content and try to steal that content, or scrape the information and use it in competitors. For example, in competitive scenarios. For example, if you're running a web e-commerce site where you have a lot of products with pricing, the bot can scrape those prices and try to adjust the price on the competitor's website, right? So how can we protect the web-facing applications using AWS services, right? So there are a bunch of services which you can use, out of which we'll talk about AWS Shield first, which actually, if you look at the where it lies, is on the DDoS, distributed denial of services portion, right? So what exactly AWS Shield is? It's a always on protection all the AWS users get, right, by default. It is tightly integrated with Amazon AWS services, and it's very flexible. Like you can turn on and off at will. You can configure the Shield rules according to your needs, right? So the Shield, and this product comes in two flavors. One is Shield Standard, and the other is Shield Advanced. So Shield Standard is something which is always on, and at no additional cost, it's available for all users. So any web-facing application you have is always protected by Shield Advanced, Shield Standard all the time. And by default, it protects you against 96% of the known threats, layer 3 and layer 4 attacks, like UDP, UDP floods, SSDP reflections, or other type of reflection attacks. And you, at beyond layer 3 and layer 4, if you want to protect your content, you can subscribe for web application firewall. So I will talk about web application firewall, AWS's web application firewall, in subsequent slides. So what with Shield, that was Shield Standard, and when you go to Shield Advanced, what are the additional benefits you get? So you get additional detection and monitoring facility. That means if let's say the volume of attack which constitutes or which gets through the criteria of being protected by AWS Shield, you can fine tune that to a lower level when you're going to Shield Advanced. You get protection against large DDoS attacks, where we work with the upstream internet service providers to prevent it at the internet service provider layer itself, even before it hits the AWS border, right? The other benefit you get is visibility into the attack and into the mitigation techniques which are available there. So in Shield Standard, which is on by default at no extra cost, you don't have the visibility. But if you go to Shield Advanced, you can get the visibility of what kind of attacks are happening and how effective your mitigation technique is there. And the WAF, AWS WAF, which I said you have to subscribe when you take Shield Standard, here WAF is included in it, right? So we'll talk about in detail what WAF, how you can use WAF in subsequent slides. The other advantage there is, you get 24/7 access to denial of service response team. That means whether you are under attack or not, you can pick up a phone, talk to our security professionals in 24/7 and get suggestions or get advice in how to fine-tune your protection rules on your border, right? And last but not least, you get cost protection. So what that means is, when your infrastructure is going under DDoS attack and you have followed the best practices for DDoS mitigation, one of the best practices is to scale and absorb the impact at the initial. Let's say the DDoS attack starts, so to absorb the impact, you will scale your infrastructure, right? So you will put more resources in it, and you can configure that to happen in a auto scaling way, right? So but when you are scaling it, you are incurring charges also, right? Because you're consuming more resources there. So with Shield Advanced, you get the cost protection. You can ask for AWS will absorb that cost, right? If you think that the resources you use to scale was again for a DDoS attack and you are subscribed to AWS Shield Advanced, you can get that reimbursed, that charge, right? So that's a very major advantage of Shield Advanced. So let's go a little bit more deep, like how we do it, right? So for large-scale large-scale attacks, what we do is we work with the upstream ISP service providers. We send them signals using BGP protocol to somehow either deviate the traffic away from your resources or black hole it, right? So that's how we work with the internet service providers to prevent any large-scale attacks. Second is border network. So our border network already have our DDoS mitigation platform deployed, which we call as Blackwatch, right? So which we have built based on our experience of running large retail sites like Amazon.com or Amazon.in and other Amazon digital properties. And we use the same mitigation techniques, or we make the same mitigation techniques available to you as we do for our own web properties. The next advantage we get is all the AWS services which are public facing, right? They are already built in a way so that they will mitigate DDoS attack on their own, right? So for example, a slow attack or SSL attacks, so these services are already built in a way that they will mitigate these common attacks out there. And web layer mitigations, now these were at layer 3, layer 4, right? So if at application layer, for the web facing applications, you can deploy something called web application firewalls, either from AWS or any trusted third party of your choice, right? And then prevent those mitigation at web layer. And apart from that, you can directly work with the DDoS response team whenever you are going under, you think you are going under attack, and mitigate the threat. So given that, if there are other features you can use is AWS VPC, right? So VPC is the default isolated network where we launch your resources. So the features in VPC which help you create a DDoS mitigation strategy is, you can choose your own IP address range from RFC 1918. You can distribute your workload across multiple availability zones for high availability, right, using subnets. And you can also use internet routing table to control what traffic goes where, right? So and once you are connected to internet, you can use security groups to decide what traffic gets into an EC2 instance or what traffic can leave out of your EC2 instance, right? So let's take a look at how you are used to doing it in traditional network, and then we will see how you can do the exact same thing in AWS VPC. So you start with application server or web servers in a private subnet, right, which is in a secured environment in your data center or in your office. Then you deploy a bunch of web servers which can be in a demilitarized zone, which have access to internet, right? And then you would have the public internet, public facing applications like load balancers, which will sit and connect to internet directly. And then you will place firewall between the web layer and the app or database layer, and you put some rules in there to only allow traffic from web server layer into application layer or database layer. Then you put a firewall between your load balancers and the web server, where you only allow the load balancer IP to initiate sessions into your web servers, right? And then finally you will put a firewall between the internet and the load balancer at the edge, right, where you allow all traffic from internet on a specific port number your load balancer is listening to, right? So if you look at the traditional approach on AWS, you will create a private subnet, you will deploy web applications in there, and then you would deploy another private subnet where you have your web servers running on it, and public subnet where your load balancer is running and connected to internet. And then you will apply security groups around each of these layer, right? So for example, on app layer you will apply a security group which will allow traffic from the web server security group, right? Or web server IP address range. At the same way, the security group which is at the application load balancer layer will take traffic from internet, right? So this is traditional approach on cloud, right? So now you can do it, you can go one step further by doing the cloud way of doing it. So the difference between previous diagram and this diagram is, instead of using the subnets, you are using the security groups here, right? So you would say the security groups allow, for the web server is allowed as a source on the application layer, right? So now if the web server layer scales up or down and the IP addresses in that range, layer changes, you don't have to go and modify a security group. The security group nesting, it's called, will take care of it. Same way at your internet edge, instead of allowing it from all internet IPs, you can allow it from just the CloudFront IP addresses, which is the CDN. And additionally, you can apply network ACLs on each of the subnet to, if you have a broad filtering requirement where you want to control what subnet can talk to which other subnet. Now, I mentioned that you can use CloudFront IP addresses, but it's something which keeps changing all the time, right? So how do you cope up with that? So the technique is, we publish those IP addresses in a public file called, we publish it in a publicly accessible file called ip-ranges.json, which if changes will generate a SNS notification, right? So you can subscribe to that SNS notification, which can trigger a Lambda. Once the Lambda is triggered, it will go and read the JSON file, find out the difference in the IP addresses, and then it will go and modify the security group, right? So you can automate that. So now if you so the next so we did at layer 3 and layer 4 right now, right? Network transport layer and network layer. Now you can how to do it at application layer, right? So that's where the AWS WAF comes in. So WAF sits at the application layer and the bad bots layer, but it has some overlap with the DDoS also, like it prevents HTTP floods also. But majority is like an application attacks and bad bots. So why do we need to, so what is the difference, right? So setting up traditional WAF is, it's complex, it takes time, you have to put it as strategic points on your network to take a look at all the traffic which you want to protect, and it takes time, right? And then once it starts looking at it, it looks at a lot of false positives, right? You have to sift through all the logs and decide what is what is a log you want to act on and what it's not, right? And then there is limited API integration there most of the time, and it's expensive. Like web application firewalls are expensive when you go with, because you have to provision for peak. You cannot make it in auto scaling mode, so you'll go buy the biggest box which will take your traffic in a peak time. So there comes AWS WAF. So what's the difference there? So first, it's fast incident response. For example, if you detect a anomaly and if you detect an attack and you modify a rule set, that rule set will propagate across all your AWS services within a minute, right? So you can deploy a mitigation at a global stage at a very short time, right? Second thing, the rule language is very flexible. So you can use to identify the endpoints, you can use regex, you can use conditions like and or, right? Or you can use both, right? And then you can use pre-published IP reputation list, where you see generally some IP addresses have a reputation of being malicious, right? So you can use that, which is published by many commercial vendors out there. And the most, I would say, in my view, the biggest advantage is using the API automation, right? So you have a lot of APIs there which you can use to automate your response. And then we also published, along with our ISV partners, we also published some pre-configured protection rules which you can just download and apply to your WAF, right? So how does it protect? We talked about this already. Highly flexible rule using pre-configured protection rules and automation, right? So let's look at what is a highly flexible rule language, right? So as I said, you can inspect any part of your request, and the mitigation you apply will be propagated to all your endpoints within a minute, right? And then the rule base is, you can base it or using conditions, or you can base it on blacklisted IP addresses which are already published, and you can act upon monitors and alarms also, right? So pre-configured rule, as I mentioned, so there are some pre-configured rule which you can use to protect your web application firewall or your applications which is taking traffic through a web application firewall, with just a click of a link where you can execute the CloudFormation template, which has pre-configured rule, which will deploy it on your WAF, right? And it also comes with pre-configured rules are there for OWASP top 10. So it's not that you know the OWASP top 10 and you buy a new web application firewall, now you have to figure out how to put the rules in there, right? So that's also pre-configured. You can just deploy it using a CloudFormation template. And talking about automation, right? So how do you automate response or automatically mitigate the responses, right? So in traditional environment, if you look, if the web server WAF is taking traffic, it's going to the servers are producing logs, which is going through threat analysis system, and which generates notification if it sees a threat. Now that notification is sent to the security engineer looks at it and then creates a new rule and apply it on WAF, right? So that takes time and it's manual. In WAF, what you can do is you can follow the same technique where the threat analysis is generating a notification. At the same time, it can trigger a Lambda function which can extract some of the information from the log and use it in the WAF to mitigate that particular threat, right? So this makes it really easy, right? So now there is one more service from AWS which actually gives you a threat detection. Or before that, let's talk about the one more automated way of mitigating threats is against bad bots, right? So if the application is taking a hit from, let's say, a bad bot, or it's trying to scrape your website, you can embed a API endpoint in your website or a honeypot, which when scraped by the bot will trigger an API, which will trigger a Lambda function, which will go and block that bot's IP address in the WAF automatically, right? So this is a big advantage you get when you are using AWS WAF. Now, with that, I want to talk about a new service which we launched last year during reInvent, is Amazon Guard Duty. So till now we were talking about mitigation of DOS attacks using WAF. Now you can use Amazon Guard Duty to shift through the tons and tons of logs you get on your AWS account, and then find out the logs which are actionable, right? Where you can look at the log and take some action to prevent a threat, right? So how does it do it? When you enable Guard Duty, it looks at 3 logs: CloudTrail events in your account, it looks at VPC flow logs and DNS query logs, and then it goes through our intelligent threat detection layer, which uses some sort of machine learning algorithms also to get a user behavior baseline, and based on the deviation it will generate some threat, some incident, some responses or logs, which you can use in your threat mitigation system to create either new rule into your WAF, or protect your web-facing application using another technique, right? So these are the type of threats Guard Duty detects. I'm not going to read all of them. The black ones you see are the well-known threats, right? And the blue ones you see here is something which Guard Duty derives based on the machine learning algorithm which runs on your logs, right? And creates user behavioral baseline and your account's baseline, right? So with all these, so how can you automate all that, right? So what you do is Guard Duty will continuously look at your environment and keep generating logs, which can be fed into CloudWatch events, right? And CloudWatch events can then trigger Lambda function to go and mitigate that threat automatically, right? Now, we talked about all this on AWS Cloud. You can use the similar techniques to safeguard your on-prem environment also in case of hybrid deployments, right? So where you deploy the security layer in AWS, right? But then connect your on-prem environment like your data center or a corporate office over high-speed links like Direct Connect, or you can connect it using VPN, IPsec VPN tunnel, and keep the web front end in AWS and utilize all the services we talked about, right? So this is how you can do it in hybrid environment. Now, I know these are the tools and services which are available to you to make your web applications more secure. But if let's say that's not your core area and you want to concentrate on your core area, so there is a list of wonderful partners we have whom you can leverage to do the same thing which we talked about in the previous slides for you, right? So you don't have to do the heavy lifting. You can use our partners.